Hello everyone, a very good evening to all. Myself Vivekananda Nayak. I am a PhD research scholar in the Department of Energy Science and Energy Science and Engineering IIT Delhi. So I welcome you all once again for this 12th interaction session on the course Solid State Physics, which is being taught this July 2024 session with course code NOC 24PH03 by NPTEL. So today we will solve a few problems that are based on electrical properties of matter. So let's start with the first problem of the day. The problem says, assuming the polarizability of krypton atom is 2.2 into 10 to the power minus 40 f meter square, calculate the dielectric constant of krypton at 0 degree Celsius and 1 atmospheric pressure. So assuming the polarizability of krypton atom is 2.2 into 10 to the power minus 40 farad meter square, calculate the dielectric constant of krypton at 0 degree Celsius and 1 atmospheric pressure. The options are option A 1.006, option B 1.007, option C 1.008 and option D 1.009. So this problem is again related to the formula of polarizability. So we have to use here the concept of polarization intensity, and from that polarization intensity we can calculate the dielectric constant, because we know the polarizability. So there is a relation that relates the polarizability with the dielectric constant at certain temperature and pressure. So we will calculate that. So I'll give you a few minutes to try this question, and then I will discuss what will be the correct option. So if we solve it, we know there is a relation that relates the the polarization intensity with electric field and number of atoms per unit volume. So the relation is polarization intensity or polarization intensity P equals to N alpha E, where N is the number of atoms per unit volume, number of atoms per unit volume, E is the electric field, and this alpha is known as atomic polarizability, which is the proportionality constant atomic polarizability. So here or we can write it in some other ways. P equals to epsilon 0 xi E, where xi is the susceptibility and this is the dielectric constant. Sorry, this is the relate. This is the E0 is the absolute permittivity of the free space. So if we from here we can correlate n alpha E. So n alpha E equals to epsilon 0 xi E. So E gets cancelled out. So you will get xi equals to n alpha by epsilon 0. Or we can write ER equals to 1 plus, because we know the dielectric constant or the relative permittivity is given by ER is equal to 1 plus psi, which is 1 plus n alpha by epsilon 0. So now we need to we know the value of epsilon 0. We know this is universal constant, and the value of alpha is also given in the question. The value of alpha is given. The value of alpha is 2.2 into 10 to the power minus 40 per meter square, and epsilon 0 value we know the value of epsilon 0 is 8.85 to 10 to the power minus 12. 8.85 into 10 to the power minus 12. So now we only need to find out the value of n. So if we calculate the value of n, then we will put all the values and we can easily calculate the dielectric constant value at the at the given conditions of temperature and pressure. So we know at standard temperature and pressure 1 mole contains 6.023 10 to the power 23 atoms. Here you see so now at standard temperature and pressure we know 1 mole of atom occupies a volume of 22.4 liters. So 22.4 into 10 to the power minus 3 meter cube. If you convert liter into meter cube to 10 to the power minus 3, so it contains 6.023 into 10 to the power 23 atoms. Now n is number of atoms per unit volume. So for 1 meter cube, number of atoms it will contain is 6.023 into 10 to the power 23 divided by 22.4 into 10 to the power minus 3, which is 2.68 into 10 to the power 25. So we got the value of n. The value of n is 2.68 into 10 to the power 25 atoms per meter cube. So now we will put the values for the expression of dielectric constant. So ER, that is the dielectric constant, ER equals to 1 plus 2.68 into 10 to the power 25 into 2 2.2 into 10 to the power minus 40, 2.2 into 10 to the power minus 40 divided by 8.85 into 10 to the power minus 12. So if we calculate, it will be 1 plus 0.0006. So here will be 1 plus 0.0006, that is 1.0006. So this is the correct option. So the correct option is option A. I hope this is clear to everyone. Now we will move to the next question. The question says, find the total polarizability of carbon dioxide molecule if its susceptibility is 0.96 into 10 to the power minus 3 and density of carbon dioxide is 1.98 kg per meter cube. The options are option A 7.27 into 10 to the power minus 40 Farad meter square. Option B 6.19 into 10 to the power minus 40 Farad meter square, 4.87 into 10 to the power minus 40 and 3.14 into 10 to the power minus 40. So this question is pretty much similar to the previous question, but here the unknown is different. So in the previous question, we had the value of polarizability and we calculated the value of dielectric constant, but here we need to find out the value of total polarizability and the value of susceptibility is given to us. And in the previous question, the value of dielectric constant we need to calculate, but there is no value of susceptibility given, so we use the formula and convert the expression for susceptibility into the form of polarizability uh, epsilon 0, that is the permeability of free space, and then number of atoms per unit volume. So here the density of carbon dioxide is given. So from the density we can calculate the number of atoms per unit volume, and then using the value of susceptibility we will calculate the value of total polarizability. So I'll give you a few minutes to try this question and then we will discuss what will be the correct option. So if we discuss about this question, so we know the density of CO2, and we know 1 mole of CO2 contains 6.023 10 to the power 23 number of atoms. So the number of atoms N for CO2 will be density into Avogadro's number divided by mass of CO2. The mass of CO2 is, mass of 1 mole of CO2 is, we know, 32 plus 12, that is 44 gram, and if you convert it to kg, it will be 44 into 10 to the power minus 3. So density is given to us 1.98 into 6.023 into 10 to the power 23 divided by 44 into 10 to the power minus 3. So it will be 2.7 into 10 to the power 25 per meter cube. Now the susceptibility we know from the previous question. Susceptibility is N alpha E by epsilon 0. So alpha E will be psi epsilon 0 by N is 0.96 into 10 to the power minus 3 into 8.85 into 10 to the power minus 12 divided by 2.7 into 10 to the power 25, which is 3.14 into 10 to the power minus 40 meter square. So the correct option is 3.14, that is option D. I hope this is clear to everyone. This was pretty much simple after we solved the first problem. So we know the value of susceptibility is I is equal to n alpha by epsilon 0. We know the value of epsilon 0. We calculated the value of n, and then the value of susceptibility is given to us. It is 0.96 to 10 to the minus 3. So using all these values, we calculated the value of total polarizability, that is alpha E. I hope this is clear to everyone. Now we'll move to the next question. Question number 3. Question number 3 says calculate the induced dipole per unit volume. Calculate the induced dipole per unit volume, that is the density of polarization of helium gas if placed in an electric field of 5 into 10 to the power 5 volt per meter. The atomic polarizability of helium is 0.2 into 10 to the power minus 40 farad meter square, and the concentration of helium atom is 3 into 10 to the power 25 per meter cube. Options are option A 5 into 10 to the power minus 10, 4 into 10 to the minus 10, 3 into 10 to the power minus 10, and 2 into 10 to the minus 10 coulomb per meter square. So these are the four options. We need to find out the value of dipole moment per unit volume, that is the polarization density. So if you remember in the first question we solved today, here we here this is the polarization intensity or density, this is P. So we need to find out this value here. So we will use the formula, and if you put the value that is given to us, we can easily calculate the value of induced dipole moment per unit volume, that is the polarization density. So I'll give you a few minutes to try this question and then I will discuss. So if we solve it, we know the density of polarization, the density of polarization P equals to n alpha alpha e into E. So we have the value of n, we have the value of alpha, and we have the value of E. So simply we will put all the values. The atomic polarizability we have the atomic polarizability. The value of atomic polarizability is given to us. It is 0.2 into 10 to the power minus 40 Faraday meter square. Then the value of electric field E is also given. It is 5 into 10 to the power 5 volt per meter. Then the number of atoms per unit volume N is also given. The concentration is nothing but the number of atoms per unit volume. So the concentration of helium atom is 3 into 10 to the power 25 per meter cube. So if we put all these values, P will be 3 into 10 to the power 25 into 0.2 into 10 to the power minus 40 into 5 into 10 to the power 5. It will be 3 into 10 to the power minus 10 coulomb per meter square. So the correct option is option C, 3 into 10 to the power minus 10 coulomb per meter square. I hope this is clear to you. This was a pretty much straightforward question. Now we will move to question number 4. It says calculate the average radius of the atom of an air molecule, if the polarizability of atom in the air molecule is 10 to the power minus 40 coulomb into meter square per volt. Options are option A 0.645 angstrom, option B 0.785 angstrom, option C 0.965 angstrom, option D 1.125 angstrom. So here the polarizability of atoms is given. So there is a formula that relates the atomic polarizability with the dimension, that is the radius of the atom or molecule. So the radius of atom of an air molecule we can calculate using that value or using that expression. So if we use that expression, we can easily calculate what will be the radius of the air molecule. So I'll give you a few minutes to try this question and solve it, and then I will discuss that will be the correct option. So AK, I am I can see you are connected. So can you please confirm, is there any background noise coming from my side? AK, can you hear me? Can you hear me? You are muted. Now you are unmuted. So can you hear me?
Yes, sir.
So can you please confirm if there is any background noise from my side or my voice is clear to you?
Sorry, sir.
So I am
Your,
asking you whether I am
your
clear to
background
you
voice
or
of song is coming.
so there is some background noise. Hello?
Okay. Tell me, sir.
So there is some background noise you are saying.
Yeah, your song is coming.
Okay, so actually there is some issue. So we will only continue for 1 hour, and then I will discuss the other part in the next interaction session.
Okay.
So that was the only issue. That's why I had rescheduled, but there was no options. So I had to take the class today. So since there is some noise coming out, so which is also uh, unavoidable in my side. So I will try to conclude the session in a few minutes. For half an hour, I will continue. Sorry, for 1 hour, I will continue the session, and then in the extra session that is planned on Monday, that is 21st October, I will do the remaining part in that session.
23rd October, sir. Okay.
21st Monday.
20, 21st. Okay.
Huh. Okay, so
Okay,
you
sir.
try to solve this question. After a few minutes, I will
Okay, sir.
discuss.
Okay. So please explain, sir.
So if we know the formula, so there is a formula that relates the atomic polarizability with the radius of the atom, and that says alpha I equals to 4 pi epsilon 0 r cube, where r is the average radius of the atom, r is the average radius of the atom. So from this expression we can easily calculate the value of r. So rq is alpha I by 4 pi epsilon 0, and the value of r will be again alpha I by 4 pi epsilon 0 to the power 1 by 3. So if we put the values, alpha I is 10 to the power minus 40 divided by 4 into 3.142 into the value of epsilon 0 is 8.85 into 10 to the power minus 12 to the power 1 by 3. So if we calculate, it will be 9.65 into 10 to the power minus 11 meter. Or if we convert it into Armstrong, it will be 0.965 into 10 to the power minus 10 meter, that is 0.965 Armstrong. So this is the correct answer. So if you see the options, the correct option is option C, that is 0.965 Armstrong. So these are a few questions that I discussed today. So uh, for giving you some overview, as you have joined late, so let me discuss these problems once more time. So the first question was related to calculation of dielectric constant. So there is a relation that relates the polarization intensity with electric field, and the same expression can be written as epsilon 0 is I. So if you equate these two, the LHS of two equations, sorry RHS of two equations, so you will get the susceptibility equals to n alpha by epsilon 0. So here if we calculate, we know the value of dielectric constant and the susceptibility. There is a relation which is dielectric constant is 1 plus susceptibility. So we put the expression for susceptibility here, n alpha by epsilon 0. We know the value of alpha that is given in the question. We know the value of epsilon 0. So we calculated the value of n, that is the number of atoms per unit volume. So at standard temperature and pressure, we know 1 mole of atom occupies a volume of 22.4 liters. So 1 mole is equivalent to 6.023 into 10 to the power 23 atoms. So 1 liter, or sorry, so per 1 meter cube per unit volume, the number of atoms it will contain is 2.68 into 10 to the power 25. So if we after calculating the value of n, we put the value of n here. So the value of dielectric constant can be calculated, which is 1.006. So the correct option, correct answer was 1.006. Then the next question, question number 2, we discussed the same concept, but here the unknown was different. So the value of susceptibility was given to us. We wanted to find the value of polarizability. This is the expression. So from this expression, the value of polarizability can be calculated as I epsilon 0 by n. So the value of n we calculated from the given value of 1.98 kg per meter cube, that is the density, and then we calculated the value of atomic polarizability, that is 3.14 into 10 to the power minus 40. And in the third question, it was pretty much straightforward. The question was to find out the value of density of polarization, and the value of alpha E and N was given to us. So simply we put the values and we got the answer of 3 into 10 to the power minus 10 coulomb per meter square. So I will stop the interaction session today here, but in the next interaction session we will solve the remaining problem. Since there are some unwanted noise, I am forced to stop this. So that's it for my side today. We will discuss more problems on Monday, that is 21st October, in the extra session.
Sir, can you send this one into YouTube, sir?
Yes, I will upload it. I
This.
will upload it tomorrow.
Okay, sir. Okay, sir. Okay, sir. Thank you.